Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So in this video lecture, I am going to discuss about the nodal analysis and supernode analysis. Okay, so here we have to discuss the following things. So first, introduction about the nodal analysis and what are the steps involved in the nodal analysis, and problems on nodal analysis and problems on the supernode analysis. Okay, so here the introduction part. So in this introduction part, first, what is mean by node? So here node is nothing but any three elements are connected at single node points or single point, we can call it as a node. So here we are having one element, and here is the second element, and here is the third element. Or let us take as this is 2 ohm, 3, and this is 4 ohm. So these three elements are connected at single node point. We can call it as a node. Okay, the three elements are connected at single point here. Okay, here is the single point. This point we can call it as a node. Okay, so here this nodal analysis is the application of the Kirchhoff current law. Here is the application of KCL, Kirchhoff current law. Okay, so here in this nodal analysis, so we are having the problems like this. So I am taking a simple circuit here. So plus minus voltage is V, and this is the resistor R1 and resistor R2 and resistor R3. So here R1, R2, R3, here in between these three we are having one node here. Okay, so here I am taking node voltage as a V1. Now apply KCL at this node point. So we'll get equation like this. So V1 minus V divided by R1. So we have to apply the KCL, Kirchhoff current law. So V1 minus V divided by R1 plus V1 minus 0. Here there is no voltage here. So means V1 minus 0 divided by R3 plus V1 minus, here also there is no voltage here. So V1 minus 0 divided by R2. That should be equal to, there is no current source, that should be equal to 0. Now by simplifying this equation, we'll get node voltage V1. Here is the equation. Okay, so in that I am taking the one circuit here, or before that the steps involved in the nodal analysis. So in that, first we have to find out the nodes. First we have to find out the nodes in a given circuit. Okay, and the second one is we have to give the current direction, and third one is we have to apply the KCL at given node. We have to apply KCL at the given node, and then we have to find out the response of the circuit. So these are the steps involved in the nodal analysis. Okay. So here I am taking the one circuit here. So in that 30 volt voltage source is there, and 2 ohm resistor, 4 ohm resistor, and 6 ohm, 5 ohm and 4 ohm resistors are there. So here in that, first we have to find out the total number of nodes in a given circuit. So here in this given circuit we are having the two nodes. The two nodes are in between 2 ohm, 4 ohm and 4 ohm. So this I am taking as a first node V1, and here also in between 4 ohm, 6 ohm and 5 ohm also we are having the another node, that I am taking as V2. Okay, so we are having the two nodes. The node 1 I am representing as the first one, second node I am representing as a 2. Now apply KCL. So here apply KCL at node 1. So now the node 1 equation is, so this is plus minus. So now apply KCL at this node 1 means V1 minus 30 divided by 2 means current through this 2 ohm resistor is V1 minus 30 by 2. So at first node V1 minus 30 divided by 2 plus V1 minus V2 by 4. A current through the 4 ohm is V1 minus V2 by 4. V1 minus V2 by 4 plus, and current through this 4 ohm. So here is the current directions. Next, current through this 4 ohm is V1 minus 0. Here there is no source here. So V1 minus 0 by 4. So V1 minus 0 divided by 4, that should be equal to 0 because there is no current source here. Okay. Then take common as a V1. 1 by 2 plus 1 by 4 plus 1 by 4 minus take V2. So V2 into 1 by 4. That is equal to the remaining term minus 30 by 2 is there. So 30 divided by 2. So V1 into 0.5 plus 0.25 plus 0.25 minus V2 into 0.25. That is equal to, so 30 by 2 means 15. Then V1 into, so 0.25 plus 0.25 means 0.5, 0.5, 1 minus V2 into 0.25, that is equal to 15. Let us take as equation number 1. Right, here is the calculation of first equation. Now apply KCL at node 2 and node 2. So here is the node 2. So the second node equation is V2 minus V1 by 4 plus here V2 minus V1 by 4 and here also V2 minus, there is no voltage source. So V2 minus 0 by 6. V2 minus 0 by 6 plus at 5 ohm V2 minus 0 by 5. V2 minus 0 by 5, that should be equal to 0 because here also there is no current source. Now by solving the equation, minus V1 into 1 by 4 plus V2 into 1 by 4 plus 1 by 6 plus 1 by 5, that is equal to 0. So this is, let us take as equation number 2. Now by solving equation 1 and 2, we will get V1 and V2. We will get the node voltages V1 and V2. Now in the given question, we have to calculate current through 6 ohm resistor, right? So here we are having the 6 ohm here. So we need to calculate the current through 6 ohm. So how we can calculate the current through 6 ohm? So the equation is current through 6 ohm means I6 ohm equal to V2 minus 0 divided by 6. So already we know the V2. Substitute V2 here, we will get current through 6 ohm here. So this is the calculation part of the nodal analysis, right? So now supernode analysis. So supernode analysis is the difference between the nodal analysis and supernode analysis is, so in nodal analysis directly we can write the nodal equation. But in supernode analysis, how we can find the circuit is belongs to supernode analysis? Means here in between any two nodes, having the one voltage source, that circuit is belongs to supernode analysis. So here in the given circuit, in between this one and in between this node, we are having the 5 volt voltage source. Then this circuit is belongs to supernode analysis. Okay. Here first of all we need to write the supernode equation. Before that, first assign the node. So this is node 1 and this is node 2. So node 1 we can represent it as a V1, node 2 represented as a V2. So here write the first supernode equation. So supernode equation is V1 minus V2 equal to 5. Directly we can take as equation number 1. So V1 minus V2. Okay. So now we have to eliminate this 5 volt voltage source. Then we need to write the equation in terms of node 1 and node 2. So here I need to redraw the circuit here. So this is node 1 and this is node 2, V1 and this is V2, and elements are 4 ohm and this is 6 ohm and this is 8 ohm, 4 ohm and this is 10 ohm. Plus minus voltage is 30 volt. Now apply KCL at node 1 and node 2. So here apply KCL at node 1 and 2. So here is the equation. Now we have to write the nodal equation in terms of node 1 and node 2. So here is the equation. So V1 minus 30 divided by 4 plus V1 minus 0 divided by 6 plus V2 minus 0 by 8 plus V2 minus 0 divided by, so these two are connected in series. So 10 plus 4, 10 plus 4, that should be equal to 0 because there is no current source in secondary side. So now take common as a V1. So V1 into 1 by 4 plus 1 by 6 plus take common as a V2, 1 by 8 plus 1 by 14, that is equal to 30 divided by 4. Let us take as equation number 2. So this is the equations of supernode analysis. Now by solving equation 1 and 2, we will get V1 value and V2 value. Node voltage V1 and node voltage is V2. But in that question, we need to evaluate voltage drop across 10 ohm resistor. We need to calculate voltage drop across 10 ohm. Means here voltage drop at 10 ohm resistor means, so first we have to find out the current value. So current through 10 ohm equal to V2 minus 0 divided by 4 plus 10. We will get some value, V2 divided by 4 plus 10. After that we have to calculate the voltage. So voltage drop at 10 ohm equal to, so current through 10 ohm into resistor, Ohm's law. So by calculating this, we will get voltage drop at 10 ohm. So here is the calculation part of the supernode analysis. Okay. So thank you one and all.